Why are we even trying to understand natural orders or formal ordering systems as an architecture student? So let's go back to ancient times, that is before the internet. When man was trying to understand the way the world was shaped and what nature could give us as inspiration, or try to understand maybe even the own measurement of our bodies, so man determined that there was this proportion, right? What is this golden ratio, the ratio of proportion? If we take a look at all of the images here on the screen, right? I show a hand in a spiral, and then I show a nautilus shell. Is there a relationship that we can determine that is similar between all of these things? Yes. So let's say that the relationship from the top of our finger to the first knuckle is the same relationship of, or compare that measurement to the top of the finger to the base of the finger. All right, that is a proportion. Let's say 1 to 1.5. You can take out your measuring tape or even just simply do it with your own hands, right? Can you see a 1 to a 1.5 relationship there? Then in ancient times, we started taking a look at the way trees were formed. The way, as an example, as I show here on the screen, the nautilus shell. And we'll look at how the proportions of the hand relate to the nautilus shell here in a minute. But when it was determined that all of these proportions were similar, what man thought was that he had kind of discovered the language of the gods. Myron Barnstone, I show a link on the bottom, gives a really great lecture about the way in which man decided to use this relationship as we started to build temples and piazzas, Italian Renaissance. They used these proportions because they thought it reflected what God wanted, a form of honor to a higher system. Or if we built in this way, we were honoring a higher system, a higher being, right? And it was our way of agreeing with this whole world and nature. And so then if we take a look, these are examples from Kimberly Alam's publications, The Geometry of Design. And what she does is she looks at a couple pieces of art to understand how this golden ratio finds its way, not even only in architecture, temples and piazzas, but also in art. So here we're breaking down a painting where the formal action occurs at the intersection of this square to rectangle relationship that we're going to draw next in SketchUp. So notice where the action is happening, right at that intersection of these proportions. So I said in the beginning, we're taking a look at the golden ratio, the Fibonacci sequence, and the modular man. So now we're on to the Fibonacci sequence. And here we start to understand the way math and a combination or dimension of measurements are used in succession to define and mathematically dimension that spiral that we form with the golden ratio. All right, so what's the Fibonacci sequence? What it is that there is a sequence into infinity. If we take a look at two numbers, so we're going to start with 1 and duplicate it just to begin. All right, so 1 plus 1 is 2, right, as we see in the image. And then if you look into the next image, up to the upper right, what we start to do is we add the two previous numbers. So if 1 and 1 is 2, and then we move on, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, and so on. That relationship can be shown in the spiral by the dimension of units, okay? So if 1 plus 2 equals 3, the dimension from the bottom of this square to the top of 3 units is then compared to 2 plus 3 equals 5, right? The next square would be a dimension of 5, 5 plus 3, 8, dimension of 8 units. And then we create a spiral that mimics this proportion of nature. To look at the units of the human body, again, one more time, you can curl your finger. We get that 1 to almost 1.5 relationship. 1 to 1.618 is what it is mathematically exactly. As I was verbalizing initially with the dimensions of the knuckle to the finger to the hand to the elbow, you can see that here diagrammed out. So why do we need to know all of this to be an architect? Okay, so once you have an understanding of your environment, right, nature, we're creating things, we're designing things to allow people to have a better life, right? Or shelter or food, right? We're fixing a problem with design solutions. So once you understand yourself and the way you move and the way you bend, you start to understand how to create a preferred environment for people. We are going to begin a new file in Revit. So remember to pick and choose the correct template. Once the application opens, we'll go under Models, New. We're going to browse for Commercial Default. If you do not open this one, you're going to have to redo your file to get into the correct template so that we all have the same screen. Click Open. Okay. Here we begin in Level 1 floor plan. We're going to draw a golden section today using the square tool and model line. Line shortcut LI. We have our drafting tools. Let's begin with the rectangle. And we're going to draw an 8-foot by 8-foot square. As we begin the command, we can either use our cursor to find 8 feet or draw a square close, tap one line, and use the dimension line in order to correct. We need to find the center of the square, so we're going to draw 2 diagonals. Again, LI, keyboard shortcut. And we're going to draw a line down from the center. Now, another way of doing that is using snaps, using LI and just hovering near the center. We're going to draw a line then from the bottom center point to the upper right-hand corner, and we're going to strike a line down. Now, we haven't used this tool specifically yet, but once we get into LI again, we're going to use Center Ends Arc. Click on the command, tap once at the center of the bottom line, tap a second time to the upper right-hand corner, and scribe until you see this dashed line that means it intersects. We have not used trim yet. TR for trimming. Trimming can extend lines or trim lines. Let's click the 2 places that we want lines to connect. So the end of the arc and our bottom line. What we'll be doing from here is to draw the rectangle to close this upper right-hand corner. I'll use LI again to scribe up 8 feet and then to close. So here we have the golden ratio. I use DI, dimension. I click on parallel lines to dimension, and then I click again to set the dimension line. From here, let's grab everything in the rectangle. So left click, drag right, let go. CO to copy. I like copying from endpoints. So I'm going to click the rectangle here and bring this down 12 feet. Take a look at what this looks like in 3D. Click on the house to get in our 3D view, and we'll see that we have our 2 golden ratio golden sections here in the plan. Now, if I'd like to rotate this into the Z dimension, we're actually not going to rotate. We're going to copy it into an elevation view. However, we need a reference plane or a wall to choose in order for Revit to understand the Z dimension and plane that we want to copy in. We haven't learned the keyboard shortcut for wall, but it is WA. If you'd like to find these buttons in the ribbon, simply go to the Architecture tab and drop down Wall. I'm going to use WA and draw a wall along the top line of the golden section. Then I will double click. We need to copy the golden section. So let's move into a view that's easy to copy from. I'll choose the top of the cube. Click left, drag right, Control C, and then go into my south view. Here I have a plane to copy it on. I'm going to Control V, which will ask me to choose the plane I'd like to copy it on. We will pick a plane. We did not create a reference plane in this file. Hover around the side of the wall and hit Tab until the entire thing highlights. Click once, and then we may place our object. If you would like to rotate this 180 degrees, we can use the button in the Modify tab or simply type RO. And Revit automatically generates a center point to rotate around, which would be fine for this. If you want to place the rotation around a specific point, hit this space bar, click an endpoint once, the line you want to rotate around, and then we can simply scroll or type in 180 degrees. If you do that, you'll need to use the MV tool because I'd like this to sit on the level 1 plane. I'm going to move back to plan so that I can create a Nautilus spiral shell beginning with the proportions of a rectangle that are in the golden section ratio. Click back to level 1. Let's copy the rectangle one more time, CO, and let's copy it 25 feet to the right and clean up everything except for the original square and rectangle. We're going to begin breaking the rectangle down in order to have smaller and smaller ratios of square to rectangle. We begin with a diagonal from the upper left-hand corner to the right. So LI, and what I will do next is move to the perpendicular at the bottom line, and from there, draw a line that is perpendicular to the diagonal. We'll see that there's a snap for the perpendicular. So I'll move there first and then extend that line, making sure that's a perfect perpendicular line. And where our last diagonal crosses the vertical, we'll draw a line from there to the left. We always want to leave the last diagonal that we drew to draft the next corner line to be perpendicular through it. Next phase is LI again. From the center intersection, draw a line perpendicular to our last diagonal. And where that line intersects, draw a vertical line. Leaving the last diagonal, so we'll delete these two, we'll draw a line from this intersection through that diagonal at a perpendicular and horizontal, deleting the last diagonal. So I'm going to move into this one more time, one smaller square to rectangle, and then we'll look at the proportions and scale. So LI one last time. From an endpoint, we can zoom in, make this a little easier on ourselves. Perpendicular and down, deleting the last diagonal. Just to show you that all of these rectangles, I've copied it and I'm pasting over, are at the same proportion to one another. I'm going to rotate this. Every time we have a rectangle that shares a diagonal, that proportion, it's easier with a line first, of the horizontal to vertical is the same. So here I type Li, choose the rectangle, and I allow all of these rectangles that I draw to share the same diagonal. So while the scale is different, this is smaller, the proportion of this line to this vertical is the same proportion as this horizontal to this vertical line. So let's take a look at it at this scale and think back to the Fibonacci sequence. 1 plus 2, if all of these were gridded into 1, 2, 3, a 1 to 2 equals a 3. A 2 plus 3 equals a 5. 3 plus 5 is 8. The proportion and the imaginary grid, if we were to add up those units, respects that Fibonacci sequence. I'll look at that again in our PowerPoint. But for now, what I'd like to do is draw that nautilus shell. We're going to draw arcs in each of the squares. Let's begin with the Li tool. And we're going to use this arc, start end radius. I'm going to click on the diagonals of the square and then allow Revit to snap so that that arc fills that square. From the bottom point, we'll start the command. We're still in the command. We'll start by clicking that upper left-hand point, the lower right, and allow Revit again to snap. So you can move through every square here until our nautilus shell is complete. Copy this image and place it in the south elevation again. It uses our same plane, and I'm going to rotate this, allowing the rotation tool to align it in the center. We can hide elements in drawings and find them again. So if the wall is disturbing you in this view for any reason, click the wall and touch Element Hide, which is EH. You can also get to that by right-clicking your mouse. I'll Control Z. Hide in view. So we're just going to hide an element. If we wanted to hide all walls, we can choose by category. To find anything in your drawing that you've hidden, there is a light bulb in the bottom of our screen called Reveal Hidden Elements. You can click the light bulb and see that the things that are in red line highlights, we can right-click and unhide. Get out of the light bulb to come back to this screen. We can even do that with levels. So if you want to hide all levels, EH, select EH. Except for level 1, we can clean up our drawing that way as well. Refer to your project assignment to understand what project 3 entails. In your sketchbooks, before you even begin drafting in Revit, you need to come up with a few iterations of these 4 things. you need to develop a bench, a table, a countertop, or a door frame. The reason we learn to hand draft first is because Revit is a limiting tool in design. It's quick drafting, you can mirror, you can rotate, you can manipulate easily, but the original thought is best when it comes between your mind and your hand. So you design first outside of the computer, and then we translate it into a digital drafted element. Let's flip back to level 1. And if you haven't saved your project, go ahead and save. Let's move on to the last item to learn today. And we're going to be introduced to Le Corbusier. He was born in Switzerland, considered a Swiss-French architect because he moved and became a French citizen in the 1930s. And we're going to take a look at what is called his Modular Man. So let's think back. We've learned about the golden ratio, the Fibonacci sequence, right? And we start to see in the silhouette of Le Corbusier's man a series of these proportions that he developed, right? As an architect, he was trying to figure out what is a comfortable step height, what's a comfortable bench height, or a stand-up countertop height, or what should a door frame be measured as, right? So what we're going to use today in order to create some furniture of our own is an image of the Le Corbusier silhouette, Modular Man, in order to develop a series of furniture that respects proportions and accurate dimensions of things that we use. So before you start to sketch out your ideas for furniture, get your measuring tape out, and I want you to measure a few things. Measure the seat height of your chair to the floor. Measure the tabletop height to the floor. Measure a dimension of the floor to the top or the opening of a door jamb. And then if you have anywhere in your home or office that is a stand-up countertop height, I want you to take a measurement of that. So note those 4 measurements for yourself. In order to use an image to reference dimensions and proportions, similar to what Le Corbusier used, we're going to just pull in, simply a drag and drop, modular image from Blackboard. Download that image, and then to place it in your plan, grab, drag, drop, and locate. The image comes in my case, rather large. Le Corbusier based all of these measurements on a 6-foot tall person. So I'm going to use the standing person to scale this image down to the accurate size. I do that by using a 6-foot line. So I'm going to type in LI, select the top line, drag my cursor down, and type in 6 feet, 1 tick for feet, enter. To rescale anything, again, I use a lot of keyboard shortcut commands and you may forget what they are. The only one you need to remember is keyboard shortcut KS. And I want to rescale this. The keyboard shortcut is RE to rescale. So we can type in scale, right? And find the shortcut. Escape. In order to scale an image, we are going to touch the image or the element we want to scale, type in RE, and click dimensions on the image first. So I'll select the top line of the man, the bottom line of Modular Man, and then drag my cursor up. So this is actually scaling the image as I drag to find the endpoint of my 6-foot line. And now I have a scaled image in Revit. Scale is really challenging because we can zoom in and out. That's why I often use dimension lines so that I can compare it to something that surrounds me. I'm going to use, you can use any of these proportions to develop your furniture. I'm going to use the Nautilus shell and create a wall. And I'm going to use the massing and site tab way of creating the in-place mass form in order to create a three-dimensional object. It allows me to touch sides of walls, transfer it into a wall. Even though it's a more complicated way of drawing a 3D element, I'd like you to challenge yourself and move beyond the component model way. So I'm going to touch in-place mass. Mass 1 is fine. And I'm in the plan view. I'm going to use the pick line tool so that I can utilize the Nautilus shell curve that I've already drafted. So pick lines, and I'm going to touch each one of these. You need to pay attention to how many times you pick the line. If you pick it twice, Revit will not understand this overlapping line, and you will get an error when you try to finish the form. I'm going to offset this mass so my wall has a thickness. I typed in O spacebar to offset, and it looks like it's going to be 1/4 of an inch. If you remember, this is an 8-foot square. I'm going to choose this to be an 8-inch thick form, and then hover. And to close the form, because everything needs to be contained, think of filling this shape up with water. Can it leak out anywhere? I'll hit escape, and sometimes I check to see that I've touched every line I need to and that the form closes just by clicking left and dragging right. Okay, I'm going to select the form so that I can drop down Create Form and click Solid. Then I'm going to look in the 3D view, hold Shift to rotate around, and I have my familiar X, Y, and Z push and pull notation. The way that the massing and site in-place mass allows you to be more specific in how you manipulate something is by the ability to touch a line and drag it separately. Anytime the form breaks, right? So that's not doing exactly what I'd like it to do. I'm going to touch that line that's created and drag it up as well. Again, if you can't quite touch the right line as you're moving through, you may hit Tab a few times, and Tab will allow you to pick different surfaces. So here, if I wanted to touch that surface, I could single that one out. When I'm pleased with the shape, and I don't understand its height yet, so you could take a look at that in the south elevation. Again, you can dimension in flat elevations, not so much 3D. This doesn't really respect, I'll do LI so that you can see the transfer line. It does not respect the golden ratio in elevation. So I think I'll spend a little more time correcting that so that the form respects the golden ratio, not only in plan, but also in elevation. So take some time, draw, and then translate those drawings digitally. Other thing to note is, why am I always drafting in between these elevation symbols? Sometimes you'll click on the south elevation and not see your object. So right now, all of my drawing is within these symbols. So when I go to the south elevation, I see what I expect. I'm going to window tile again. That shows me everything in all of the tab drawings I have open. And I'll show you what happens to my south elevation if I move this object with beyond that. If I click the little triangle once, I see the line of what I view in front of me. So if I place this object on the other side of that line view, it's no longer going to be in the south elevation. So my mass model is constrained to that XY. Let's experiment with the wall. So I'm going to touch this wall and move it beyond the south elevation, and then you can stare at what's occurring in that bottom frame, and the wall is gone. If I move the elevation line back, the wall returns. So now I'll allow you time to complete your furniture.